with, for example, um, like this. And first of all, initially I should set the working directory and should also name the file, but because I'm making just a tutorial, so it's okay. And with parts I just create a cd specimen. It's good if you write names, because then you can just relate back to them always when you want to change them, or you want to see what you defined in there. So uh, because it is a simple geometry, I'll make it 2D planar, shell deformable. Yeah, approximate size shows the grid which is on your screen. If I want to make the geometry in millimeters, I'll set it to, like, for example, 2 or 3 or something like that. Yeah, and here I can just make a specimen, a square specimen, and then I can put in a calculator. Okay, so this is a specimen, and let's check its dimensions. I want it to be 20 millimeters, uh, this way, and uh, 20 millimeters this way. uh, okay, that's what I want to do. And so here is my specimen. Now what I want to do is that I want to section it from here and from here, and I want to define two different kinds of, or three different kinds of materials here. So what I'm going to do now is that I'm going to use this section command, create partition command, and I have to partition a face. And yeah, I'll do it by sketching. So when I click it, it automatically gets into the sketching mode, and here I can, what I can simply do is I can just put a reference line here. um, uh, yeah, uh, make it like fixed, so just in case it moves in the future. um, okay, and what I want to do is that I want to create a partition here. For example, if this part is welded, and the rest of is base metal, so for this case I want to like mirror it. It is asking me if the type of mirror is copy. Yeah, it is copy. Pick the mirror line, I pick this, and then select the entities to mirror, and I pick this, and there it is. So what I'm gonna do next is I'm gonna yeah, I'm gonna give it the dimensions. For example, if it was 20, I want it to be at 5 millimeters from the center, or 3 millimeters from the center. Hi. Okay, so after dimensioning it, now I have uh, now when I let's see what happens when I done it. Oh, oh, oh. Uh, I made a mistake. What I should do is that I should um, close this geometry, because I am partitioning the faces. Yeah, yeah, here it is. So we have this partition, this partition, and then this partition. Now we have like one specimen defined, but I partitioned it from here and from here. So now we have like 3 sections of one specimen, and they are only virtually defined. They're not like practically separate pieces. They're practically one piece, but virtually have 3 sections now. And there, this is where I put in like material. For example, if I call it material one, and then probably if somehow this is base metal and this is welded nugget, I'll have material 1 for base metal and material 2 for weld nugget. So material 1 is mechanically elastically elastic. Let's say it has Young modulus of 210 gigapascal and Poisson's ratio of 0.3, and or material 2, which is of the welded material, has elasticity of, let's say, it is really soft. It has elasticity of 180 gigapascal and Poisson's ratio of 0.3. And when we do this, we have to actually define 2 sections. um, Section 1, let's say it is of base metal and it is homogeneous, it is solid. Continue. I want to select the material. It is material 1, which and plane stress and thickness is the virtual thickness of the physical thickness of this specimen in z direction. As we define the specimen in 2D, we cannot actually see it, but ABAQUS will use this stress strain thickness ratio to actually simulate it as if it was that much thick. So we can actually give it the stress strain thickness of like 5 millimeter. Okay, this is base metal, and then this is weld nugget, and then I can select material 2, and I can also give it stress and thickness of 5e minus 3. So now we have defined 2 sections, and I want to assign these sections to their respective portions. And what I'll do here is that section assignment, double click section assignment. It asks you select the regions to be assigned a section, and I select this, keep pressing shift and press this, and then these both are selected, and I press done, and then I select base metal, like they are the base metal. Okay, and they turn blue, and then I define section assignment, and it asks me again select the regions to be assigned a section, and I select this section, and I press done, and then weld nugget. Okay, and then I press okay, and then the whole material has been, the whole specimen now has been defined section, so it is all blue. Now I have assigned those sections, but the sections originated from the materials. If I'll change the properties of the material 1 or material 2 here, I'll only have to double click it, and for example add plasticity to it, or add something to it, or change the Young's modulus. The properties of the respective section will automatically change, and the simulation will run for something new. Uh, I hope you get my point here. I only have to change the materials here. The sections are using these materials, and the specimen has been assigned those respective sections. So if I change the material properties here, the properties of the respective sections to which those sections have been defined will change. Well, okay, now what I want to do is I want to do assembly, and I want to bring it here. Okay, and there goes the coordinate, there go the coordinates, so I just want to delete them so that I can visualize it. Okay, and what I want to do here is that I want to define a crack. Yeah, and I want to define it through XFEM, and it is, I name it just crack. Continue, and that's what I want to do. Crack location, let's say we make a crack here, assembly section face sketch, Okay, we have to make it independent. Make independent. Now it is independent. Now we can actually sketch. Done. And I just make a crack here. You can actually define a crack using the contour integral command. I just want to keep this simulation simple, that's why I'm using the XFEM command. So just bear with me. XFEM, let's say it's crack, continue, select the crack domain, it is this one, and crack location is this one, and I don't want to specify contact property, and the crack is allowed to grow. Okay, so doing this, just make things really simple, and then in the steps I want to define static channel step with time period 1, non-energy geometry off, increment is, let's say this. Okay, field output, history output, and history output we want to get for the crack um, the value of J integral. Okay, missing values, number of contours is 5, let's say 5. Okay, and yeah, that's it, I think. Yeah, and finally we'll have to mesh it. Boundary conditions. To put boundary conditions here, I need to use the initial step for fixed bottom, and yeah, this part of the specimen is fixed, and then I want to like apply displacement on the top, this top, and symmetric is asymmetric now. Mechanical continue. I want to do this, and in U2 in Y direction I want to have it a positive displacement of 5 mm. Okay. And a very important thing, if you want to apply residual stresses in the section of the crack, what we do is we apply a predefined field in step 1, and I cannot apply mechanical. Okay, here I have to select the initial, and then I can apply mechanical, and there are the stresses. I want to name it residual stresses. Stress, continue, and then I'll select this area. Now when I select this area, it gives me sigma 1 1, stresses in x direction, stresses in y direction, stresses in z direction, stresses in shear direction, xy shear direction. So what I do is, I don't want to apply stresses in x direction, 0. I don't want to apply stresses in y direction. I don't want to apply shear stresses, but I do want to apply the compressive stresses in y direction. So I'll give the value of minus whatever the compressive stress is, 200 E6, 200 MPa, for example, let's say. And now this area has got a residual stress of 200 MPa in the compressive direction, from y to this side, and then from here to this side, not in x direction, not in z direction, only in y direction. See? Okay, and then we just need to mesh the whole geometry. We'll use mesh controls. It says select the area you want to control the mesh in. We select the whole area, and then we have quad structured. Okay, let's say quad dominated. Okay, and apply this. Well, this, well, this, okay, and mesh it. You won't see the mesh here because I'm using it in, I don't know, Linux, and I have not set the environment really well, but it has been meshed, and now we just save it. Mm, mm, and make a job out of it. um, and want to rename it as rename cd compression cd 3 mat compression, and cd 3 mat compression. And yeah, let's sum it and try. Let's see if XFEM cracks. Okay, okay, I did something wrong here. It doesn't apply to XFEM. Hmm. We don't know if the crack will open or not. Oh. Oh. Um. Because I cannot see the mesh, I have problems with it, but um. Hmm. But that's normally how it will go. Um. We'll have to check for if we can solve it quickly by remeshing it. Hmm. Two. Yeah, and then remeshing it. No. Hmm. God dominated free. It is having a problem, but that's how it will just execute. This is how you can define your problem with contour and integral crack in the center, and then the tip will have the exact right mesh on its tip, and it will execute. So thank you for watching the video. We'll keep you seeing later. Bye.